Welcome back, everyone. Machine learning has taken the market by storm, and there is a varied interest in individuals from different backgrounds that want to get into this field. Nowadays, IoT devices, sensors, and CCTV cameras are all used to collect data, provide some useful insights to learn new findings, and explore new areas of improvement for the company. There are some basic fundamental steps that are needed to learn in order to get a hang of the machine learning algorithms. Let us begin with our first type, that is supervised learning. This learning includes algorithms that are designed based on a target variable which is to be predicted or calculated with the help of a given set of independent values known as predictors. Starting from the analysis of a known training dataset, the learning algorithm produces an inferred function to make predictions about the output values. Let us now begin with our second part, that is unsupervised learning. This learning includes algorithms that are used for clustering, as it has no target variable of the coefficient to predict in the picture. K-means and a priori are the prime examples of this learning. Unsupervised learning studies show how systems can infer a function to describe a hidden structure from the unlabeled data. Moving on to the third type, we have reinforcement learning. Reinforcement machine learning algorithm is a learning technique that interacts with its environment by producing actions and discovers errors or rewards. Trial and error search and delayed reward are the most relevant characteristics of reinforcement learning. This enables machines to automatically determine the ideal behavior with the specific context in order to maximize its performance. Machine learning as a concept was derived from statistics as its base. Statistics is the subdivision of mathematics that deals with data collection, categorization, interpretation, and presentation. It basically can handle all phases of data, including the planning of data collection in terms of the design of surveys and experiments. At times when companies need a profitable business model which can deliver in terms of flexibility and reliability, they are bound to apply machine learning techniques to deliver immense value to the business. While hosting these ML and AI services, the company has to look into some glaring factors which could shape the foundation of these technologies. Let us now talk about reinforcement learning. And to begin with, we'll discuss reinforcement learning in ML. Machine learning has an integral part to play in reinforcement learning, as the agents learn from their mistakes and ensure that it won't repeat again. But unlike machine learning, where the machine is expected to produce a certain output, this learning trains agent come up with their own observations and inferences. There are certain algorithms of control learning that are used to execute this process, like a criterion for optimality, brute force, and direct policy search. A good example of reinforcement learning is the Boston Dynamics' newly invented agent, Spot Mini. It was designed and manufactured on the principles of self-learning and self-evaluation, which made it easy to overcome external circumstances while closing a door. There is a small video that was released by Boston Dynamics showcasing what it is capable of. As scary as it may look, humanoids surely are learning to live and melt into their surroundings, even if any external intervention is certain. In this video, the tester is trying to block the agent's way to open the door, but clearly it outshines the human intentions and opens the door with great ease due to reinforcement learning. Let us now discuss about reinforcement learning in artificial intelligence. Reinforcement learning is an important foundation for artificial intelligence. It has dynamic programming mechanism which trains the agent, that is, the machine, using the constants of success and failure. It needs to have an uninterrupted interaction with its current surroundings by observing and gaining knowledge from it. This process is carried out for quite some time until the host understands the difference between right and wrong. This is carried out considering the fact that external human intervention is minimal, so that the agent learn and interpret the current scenario on their own. Statistics deals with data collection, preparation, examination, and presentation. Data such as statistical population or statistical model analysis are taken care of with the help of stats. Statisticians were the first one who used to come up with interesting insights and findings using different statistical techniques in data before machine learning became mainstream. They used to undergo the task of assembling the measurements of the system under the radar, manipulating it, and in the end capturing additional measurements of the same system using the same technique to determine if the manipulation has changed the values of the readings or not. Let us now have a look into some of the important terms in stats which are fundamental in machine learning. Let us begin with mean and median. So first, talking about mean, it is the arithmetic average of data values. It comes under the central tendency of stats. Mean takes into consideration all the values for computation. Now, let us know about median. So, median is the central observation when all observations are arranged in order of magnitude. It is an important measure of central tendency. Median is the observation that divides the series into two equal halves. Let us now learn about skewness, kurtosis, and variance. So to begin with, we'll first talk about skewness. So, it illustrates the level of degree a set of data varies when compared to standard distribution in a set of statistical data. Its resultant curve depends on the data, whether the data is having a positive or a negative skew towards the data average. Now, let's move on to kurtosis. Kurtosis measures the data for light-tailed, which means less outlier prone or heavy-tailed when compared to the normal distribution. Variance. So, variance is the measurement of the span of numbers in a data set. It is also the square of standard deviation. Welcome back to the course. We are now going to discuss about some of the machine learning models. And to begin with, first of all, we'll be discussing about regression models. So, there are three types of regression models. And first of all, we'll be discussing about linear regression. Linear regression is a part of the predictive analysis and is the common algorithm used for prediction of data values in numeric form. Both the input and output values are supposed to be numeric. There is one coefficient represented by beta in the linear equation of linear regression. Another coefficient is added, providing the line an additional degree of freedom, which is known as the intercept. A simple regression problem would be classified by using this equation. The overall notion of regression is to examine two important criteria. First, does the given group of input variables do a capable job of predicting the dependent variable? And second, which variables in particular are the real predictors of the dependent variable and what is their impact on the outcome variable? So, reliability of our linear regression model can be tested with the help of the following functions. First is the line of best fit. Let us now discuss about it. The line of best fit is a validation line which explains the direct correlation between the observed values and the calculated ones. It helps in understanding the difference in distance of the predicted values to the real ones. This distance is known as residual. These residuals are symbolized by the vertical lines showing the comparison between the predicted and actual values. The graph gives us a simple understanding of how this works. The blue line, which is separating the points, is our line of best fit, which gives a clear indication of the exact difference between the original values and the predicted values. For calculating the distance between the line and the points, we need the following formula, that is, of the residual, where hx is the predicted value and y is the actual value. The second type of function is gradient descent. Gradient descent was introduced in linear regression in order to find the minimalistic cost of a function in the equation. Depending on the convex function, the gradient descent function gradually makes some small changes to its parameters in order to minimize a given function to a possible local minimum if necessary. There are two important terms in the gradient descent. These are the learning rate and cost function. The size of each step that we take in our model is measured by the learning rate. The curve plotted from our model has its own slope, which updates us on the parameters and how to make our model more accurate. This is known as the cost function. The next regression model that we'll be studying is a polynomial regression. Just like linear regression, a polynomial regression model is used to find the relation between a dependent and an independent variable. The only difference is that at times in linear regression, the line of best fit may end up underfitting the data points in the picture, as it couldn't capture the necessary trends and patterns in the data. Hence, polynomial regression plays a crucial part in improving this model and finding a more subtle relationship between the variables. A regression polynomial is represented by this equation. The line of best fit is actually a straight line in linear regression, whereas in polynomial regression, it is a curved line. If we consider the case of underfitting, then this can be resourceful. But at the same time, when we tend to increase the accuracy of our model, we might end up overfitting it, which is also not recommended for real-world implementations. Hence, we need to observe the nature of the curve and make changes in our model accordingly. Focusing on the curve at the ends and checking whether those trends make any sense is vital. Sometimes, higher polynomials will end up producing mysterious results on extrapolation. The third regression model that we are going to discuss now is lasso regression. Least absolute shrinkage and selection operator is similar to ridge regression in terms of working, which changes the size of regression coefficients. It can also reduce the variability and advances the accuracy of linear regression models. Lasso regression handles the real absolute values in the penalty function rather than squares like in ridge. This enables it to penalize values which cause some of the parameter estimates to be exactly zero. If the penalty is high, then the estimates get shrunk to zero. This results in variable selection out of the given n variables. Some of the assumptions that are made in this algorithm are as follows. So, firstly, the assumptions of this algorithm are the same as that of the least square regression, except for one thing, that normality is not to be assumed here. Second, it shrinks the coefficient to zero, which makes it easy for selection. Third, this is a regularization technique and adopts L1 regularization. And the fourth assumption is, if a group of predictors is highly correlated, then it picks any one of them and shrinks the others to zero. Welcome back everyone. Moving ahead with the course, we'll now study about the second type of machine learning model, that are clustering models. We'll start our study of clustering models with its first type, that is, the k-means clustering. So, k-means clustering comes under unsupervised learning algorithm. It is utilized for unlabeled data. That is, the data points do not belong to any group or category. The modus operandi of k-means is to determine the number of groups present in the data, and these groups are represented by k. This algorithm works in a way which assigns each data point to one of the k groups iteratively based on the features that are already present in the dataset. These data points are clustered together based on similarity. Clustering can be used for exploratory data analysis to get a rough estimation of the structure of data. It is usually assigned to find the subgroups in the data where the data points in this subgroup are similar to each other in characteristics, while points in the other groups are different. K-means has the job of polarizing homogeneous subgroups within the data, wherein all the data points in all the groups that exist within the data are similar. The basic steps used to cluster any data point for any data are as follows. So, at first, define the number of K clusters. Secondly, initialize the centroids by randomly selecting K data points for clustering. Third, perform this iteration until there is no change to the centroids. Next, we calculate the sum of the square distance between the data points and all other centroids. Now, assign each data point to the closest centroid or cluster. Lastly, estimate the centroid for the clusters by taking the average of all the data points that are assigned to each cluster. So let us now look at some of the business use cases of K-means. The first use case is of managing sensors. So sensors collect data of different types like audios, images, etc. in its database. K-means is used to separate that data and create different categories. Our next example will be of managing inventory. An inventory consists of diverse data like sales activity, manufacturing data, export-import data, etc., which is grouped into categories by k-means. Moving ahead with our study of clustering models, we'll now be looking at hierarchical clustering. Hierarchy is the level of clusters that are involved in the dataset. Hierarchical clustering involves groups of clusters which are merged into the nearest similar cluster until they form a single cluster for the entire dataset. Its working can be shown in the form of a dendrogram. Here we can see that a total of 25 points are present in the dataset, which is assigned to separate clusters. As this algorithm works, two closest clusters are merged until we reach a point where a single cluster is available. The height in the dendrogram, where the clusters are merged, displays the distance between these two clusters in the data. Hierarchical clustering can be of two types. We'll start this by studying about divisive clustering. The divisive approach, which is also known as the top-down clustering, includes data points which assigned to a single cluster is later segregated to two or more similar-looking clusters. Each cluster is examined recursively until the algorithm settles for one in the end. It is true that the divisive approach has more rewards compared to the agglomerative approach due to its capability of producing more accurate hierarchies for diverse datasets. The second type of approach which we use is agglomerative. Agglomerative approach defines a bottom-up approach. Then it assigns the clusters to data points and merges them with each other just like divisive to gain a single cluster for the dataset. For performing any clustering operation, it is mandatory to introduce a proximity matrix which contains the distance between each point with the help of a distance function. This matrix needs to be updated for it to display the distance between each cluster. The following three methods are used to check the distance between each cluster. So the first method which we will be studying is single linkage. Single linkage technique includes the concept of defining the distance between two clusters as the shortest distance between 2 points in each cluster. In this case, the distance between the clusters R and cluster S is equal to the length of the arrow measured between their closest points. The second method is of complete linkage. The longest distance between points of two nearby clusters, which can also be termed as the longest distance for each cluster, is defined in the complete linkage. In the given case, clusters R and cluster S are equivalent to the length of the arrow as shown in the image. Our third and last method is of average linkage. This defines the average distance between data points of two nearest clusters. In the given case, the cluster R and cluster S are equal to the average length.